All right, we're going to hop into daily 22 here. We are going to be continuing solving our quadratic equations by factoring. The difference between today's lesson 22 as compared to lesson 21 is that today I'm going to have a numerical value in front of my variable squared. It's going to be more than a 1b squared. Here I've got a 3b squared, 2b squared, a 7x squared in examples 3 and 4, and a 4x squared and 6x squared in examples 5 and 6. So here's where I have to use that guess and check factoring. So these are going to take a little more time to go through more than likely because you're not always going to get the correct guess down on that factoring right away. It's not, what two numbers multiply to make your C and add to make your B. There's a little more, skill or luck, depending on how you look at it, involved. Same ideas. We need to make sure our equation is equal to 0 before we attempt factoring. And using that zero product property, we're not going to be able to just use the opposite of my back number here. We're going to actually have to set up an equation to solve here, but I will give you a little shortcut from doing the quad solve video, which we will look at as a class, to show you how to do that solution correctly and efficiently. So since in example 1 my equation is equal to 0, I am ready to start my factoring. Since 3 is a prime number, the only way I can get to 3b squared is by 3b and 1b. That's the only way I can get 3b times b to get 3b squared. That being said, I am now looking to get a product of positive 2 at the end. So is it 2, 1, 1, 2? It has to be the same sign. Looking at my middle number, negative 5, I know the sign has to be negative, negative. Negative times negative is positive, and then two negatives combined will make a negative 5. So now I need to check, is it 1, 2 or 2, 1? Order will matter. If I go 1, 2, let's check it. 3b squared. 3b times negative 2 is negative 6b. Negative 1 times b is negative 1b. And then negative 1 times negative 2 is positive 2. So as I look here, negative 6 minus 1 is negative 7b. That's not good. So my guess there was incorrect. So I'm going to have to do a little cleaning here and get the opposite guess checked. So I guess I could have left that up there, but we're going to switch the 1 and the 2 around. Let's go 2, 1. So I'll have 3b squared. 3b times negative 1 is negative 3b. Negative 2 times b, negative 2b. And then negative 2 times negative 1 is positive 2. So here we go. Negative 3 minus 2 is the negative 5. So here is the correct factorization. So I need to know now, what number can I plug in for b so that when I multiply it by 3 and subtract 2, I get 0. Using that zero product property, I want either my first parenthesis value to equal 0 or my second. So the first parenthesis said it may not be obvious what b should be. So if it's not obvious, use your inverse operations. Add 2, add 2. 3b equals 0 plus 2 is 2. Divide by 3, divide by 3. b would equal 2/3. Second equation, parentheses set, it's probably a little easier. Add 1, b equals 1. So how could you get this 2/3 using a little efficiency? There'll be a shortcut. It's exactly what you want. It's the opposite of the back divided by the front. What did I just say? Well, here it is. The opposite of the back is -2 and the front is 3. So the opposite of the back, opposite of -2 is 2, divided by the front, 3. 2/3, 2/3. The opposite of the back, opposite of -1 is 1, divided by the front, 1. 1 divided by 1 is 1. So, if you don't want to go through your equation there, format will always be opposite of the back divided by the front. Don't you just love that? Oh, great, great, great. All right, let's take a look here at example 2. Opposite of the back divided by the front. Don't forget that. It's a good little jig. 2b, 1b. I think to get 21, I can go 3, 7, or 7, 3. I think if I go 3 and 7 in that order, I will have the correct factorization. Because 2 and 7 gives me 14b, 3 and b gives me 3, 14 and 3, 17. So now I'm ready to solve. If you want to write it out and go through the inverse operations, great. Or you could say, hey, b is equal to the opposite of the back. So the opposite of 3 is -3, divided by the front, 2. Done. Or, in this case, what number plus 7 is 0? -7. Or, of course, you could go opposite of the back. Opposite of +7 is -7, divided by the front, 1. -7 over 1, -7. There are your two solutions. Happy birthday. All right, 3 and 4, we need to get our equations equal to 0. So I'll move my 31x and 20 over using inverse operations. So 7x squared minus 31x minus 20 equals 0. And I'll try to get through this efficiently, but just know that, hey, you might not always, get the guess and check right. So just know that I've got a little more experience. Not that I'm, tooting my own horn here, but it just is what it is. All right. So when I look to find products here, I need to find two numbers that'll give me a product of -20. I think if I go -5 here and +4 over there. The reason I did that is I could visualize that 7 times -5 is -35. And then 4 times 1 is 4. So that gives me -35 and 4, -31. Again, I have the experience. You might have to guess and check. No problem. All right, so now I'm ready to solve. When I get any equation factored, I'm ready to get my solutions by taking the opposite of the back. So the opposite of 4, -4, divided by the front, 7. And in binomial 2, I can visualize that 5 minus 5 is 0. Lovely. All right, example 4. Subtract 28 from both sides. I'll have 7x squared minus 45x minus 28 is 0. 7x squared, I'll get 7x 1x. And, all right, let's see. I think if I go -7 and +4 here, 7 times -7, -49, and 4 times 1, 4, -49 and 4, -45. So we're good. Similar to my prior example, opposite of the back divided by the front, solution 1. And then x could be +7 here for solution 2. Finally, here with the last 2 examples, you are free, I'll just show you here either way, First you want to get, of course, your equation equal to 0. So we got 4x squared minus 2x minus 6 equals 0. You can always take out a greatest common factor. If you see here that, 4, 2, and 6, I can take out a 2 from each of these terms. That would leave me with a 2x squared minus 1x minus 3 equals 0. You don't have to. You can guess and check right away from a 4x squared. Totally good. But sometimes if you take out a greatest common factor, that'll ease the factoring a little bit. So 2 out here is just a PFD, personal flotation device. Working on the remainder here of 2x squared minus 1x minus 3. I need 2x and 1x multiplied to give me 2x squared. I'm then going to do a little guess and check here to get my negative 1x in the middle. So if I go 2x times 1, that's 2, and then negative 3 times 1 is negative 3, 2 minus 3, negative 1. So I'm good there. So my solutions are going to be, again, this 2 has no impact on the solution. It's just a floater. What number can I plug in for x here to make this binomial 0? The opposite of the back, the opposite of negative 3 is 3, divided by the front, 2. And then what number plus 1 is 0? That would be negative 1. So if you want to factor out, again, go for it. You do not have to. You can go guess and check from the 4x squared. All right. So let's take a look at the final example here, getting my x squared alone with everything else. Get my equation equal to 0. 6x squared plus 3x minus 9 is 0. Here I can see that 6, 3, and 9 all have a factor of 3. So if I divide all these terms by 3, I'll have 2x squared plus 1x minus 3 equals 0. So 2x squared, very similar to above here. 2x, 1x. But now I want to go plus 3 minus 1, I think. No, that's not right. Come on, Atkinson. I think I want to go plus 3 here, minus 1 there. Again, you might think you're quick, smart. Even someone like me, I think I am. I must not be. You can sometimes make a little quick error. Always double check. 2x squared, 2x times negative 1 is negative 2x. 3 times 1, 3x. 3 minus 2 gives us the 1x. All right. So I'm ready to find the solutions here. First binomial, opposite of the back, divided by the front. And 1 minus 1 is 0. There we go. Crazy bread. I got good news for you. If you don't like the guess and check factoring, we've got the quadratic formula coming up next lesson. So today may be the only day that you have pain and suffering in your life from quadratics. Stay strong, keep battling.